Hello dear students, let's see this question of JEE Advanced 2015. The question states, a spherical body of radius r consists of a fluid of constant density and is in equilibrium under its own gravity if PR is the pressure at r smaller than capital R, mean inside the volume, then the correct option is R. So this question is inspired by a question of Erado 1.216. In that question we have to find the gravitational pressure at an side point of a planet or any spherical body. So I'll derive that result, and using that derivation I will immediately get which of the option is correct. So here is the question of the Erado. So this is a spherical body of uniform density rho and total mass m, radius r. We have to find the gravitational pressure at a distance small r inside this spherical body. R is the distance from the center. So before that, I'll recall the result of gravitational field at a distance small r from the center, and that gravitational field is G is equal to minus Gm by small r by r cube. R cap is a unit vector in the radial away direction. This minus sign that gravitational field is towards the center. So suppose now we are somewhere here at all these points which are at a center at a distance small r from the center. We want to find the gravitational pressure here. So, and to do that, what I am going to do, I am just making a kind of a cylinder. This is a cylinder from radius small r. This is a small r. So it would be better if I show this small r this way. This is small r till capital R. The area of cross section is very small dA. And the forces that this cylinder is getting acted upon from these two sides, the forces, they will balance, and then this part is pulling it downward inside, and if the pressure at this position is P, so because of the pressure there will be force P into dA upward, and this whole system is in equilibrium, so this part is also equilibrium. So first of all I'll find the force on this part because of this central part. Because of here and here the forces are cancelling. So for that, what I am going to take, I am going to at position X from here, and take a little section of this cylinder of length dx. So this section is dx. I think that would be visible from there. So that section is dx. So the mass of this part would be, the mass of this part dm would be density into volume. Volume is equal to dA into dx. And acceleration due to gravity or the gravitational field here is towards the center, and this is at a distance r from center. So at a distance x, gravitational field will be towards downward direction in place of small r. This is the magnitude. So the gravitational field will be gmx by r cube. So the force on this part, because of this whole central sphere of radius small r would be, this force I am writing as a df on little part of length dx. So that df would be dm into gravitational field at that location, and that gravitational field is gmx by r cube. So df would be how much? Df would be g capital M by r cube, and dm is rho into dA into dx. I can write everything in terms of the mass. So this m can also be written rho, I can write m upon 4 pi by 3 r cube, right? So that I have written in place of the density. So that will become gm square dA into dx, and here there is a 3, let me take the numerator, and that would be 4 pi r power 6. All right. Is there any expression of x? There was some expression for the x also. Gmx it was. So there will be an x here. Yes. So overall force on this whole cylinder, that overall force will be the integration of this df. So that df would be, the integration will give me 3gm square divided by 4 pi r power 6, and dA, let dA will be there, dA same everywhere, x dx, and that integration will go from small r to capital R. So small r to capital R, so we will get finally the value of f will be, this will be x square by 2, and if I put the limit, so I will get finally 3gm square divide by 4 pi, that will become 8 pi r power 6 dA, and multiply by r square minus small r square. So this is the force there. And now if I draw the FBD of this part, so what is there? Pressure at this location is P. So because of this pressure, there will be of upward force P into dA, and there is this force F. Whole system is in equilibrium, so this part will also be in equilibrium. So equate these two parts. So what I will get, simply P dA is equal to F. So P is equal to, and that F we have calculated, so P is equal to F by dA. So if I divide by dA here, so this dA and this dA will get cancelled. So what is the final force? Final force is 3gm square divide by 8 pi r power 6 into r square minus small r square. We can further simplify, and this is now P. We can take r square outside. So this P I will get finally 3gm square, r square I am taking outside, so 1 minus r square by capital R square, and that will become 8 pi r power 4. So we have to compare the pressure at different points. We have to compare the pressure at different points. So this whole thing is a constant. So I can write pressure at distance r is equal to, let me write this whole thing as a some constant k. So I can simply write k into 1 minus r square by capital R square. This is the expression that I'll be using. Now let's see all the options for one by one. So first option is, option A is P. Option A is saying pressure at R is equal to 0 is 0, and that is actually the question of Erado. So R is equal to 0 at the center. So if we go to the R is equal to 0, we'll get the pressure equal to K, and if we put the value for the earth, that will come out to be, million times of the pressure compared to the atmosphere pressure. So obviously pressure at the center of earth is enormous. So this option is incorrect. And then option B. Option B is saying pressure at R is equal to 3 by 4 capital R, and divide by pressure at R is equal to 2R by 3. So I'll compare here, k will get cancelled, so that will be here you can see that small r by capital R is 3 by 4. So small r by capital R is 3 by 4, so r square minus capital R square is equal to 9 by 16. So 1 minus 9 by 16, here small r by capital R is 2 by 3. So 1 minus 4 by 9. So on simplification, this will become 7 by 16, and that will become 5 by 9, 35 by 80. So 35 by 80, so this is also incorrect. Option C, pressure at R is equal to 3 capital R by 5 divided by pressure at R is equal to 2R by 5. So here R by capital R is 3 by 5, so 1 minus 9 by 25 divided by 1 minus 4 by 25. So that will become 16 by 25, and that will become how much? 21 by 25. So that will become 16 by 21, and this is a correct option. And D is P at R is equal to R by 2 divided by P at R is equal to R by 3. So that will become 1 minus small r square by capital square, mean 1 minus 1 by 4 divided by 1 minus 1 by 9. So this is a 3 by 4, and this is a 8 by 9. So that is actually 3 by 4 into 8, and 9 will go there. So that will be 27 by 32. So this is also an incorrect. So only correct thing is C.